Hello, students. Let me go ahead and show you how to multiply double-digit numbers by double-digit numbers. So this is what we're going to learn in Chapter 1, Lesson 7. So if we have 28 times 18, when we want to estimate, we will have to round both of these numbers to something easier to multiply by. So 28 is really close to 30 and 18 is really close to 20. So now what we have here is we've got two numbers ending in zeros, really easy to mentally multiply together. First, use the base fact, 3 times 2. 3 times 2 is 6. Then count the number of zeros in both factors. We have 1, 2 zeros, so that means we need 2 zeros in the product. So our estimate is going to be 600. So now, how do you multiply this out? Well, first I'm going to show you the classic method. Okay, this is the method that we're supposed to teach in 5th grade. So what you would do here is you would multiply the 8 times the 28, and then you would multiply the 1, which is not really a 1. I'll explain that in a moment. Then you would multiply the 1 by the 28. So if we take the 28 and multiply it by 8, we would, of course, first go that way, and then we would go 8 times 8 and then 8 times 2. 8 times 8 is 64. 4 goes down. 6 gets carried or regrouped. 8 times 2 is 16 plus 6 is 22. Now, we're going to have to multiply the 1 times the 28. But this is not really a 1. Remember I said that a few seconds ago? The 1 is sitting in the tens place of the 18. So this 1 is actually a 10. Now, since this 1 is a 10, we are going to have to start our second partial product with a 0. Okay? Because whenever you multiply anything by 10, the product will have a 0 in the end of it. So now all we have to do is multiply 1 times 8 and 1 times 2. Notice I didn't include the 6 when I multiplied 1 times 2 because that didn't go with 1 times 28. That went with 8 times 28. Okay? Now, we've got these two partial products. Okay, these things are called partial products. And the reason they're called partial products is because they're not the whole product, they're just part of the product. In order to get the whole product, you have to add. So you add 4 plus 0 is 4, 8 plus 2 is 10, 0 goes down, regroup the 1 into the hundreds place, 2 plus 2 is 4, plus the 1 we regrouped is 5. Okay? Now, let me show you another way to do this, which is what we call the matrix method. The matrix method is where you would have learned this in 4th grade because they're supposed to teach this to you in 4th grade. We essentially draw like a window in a house. And we take 28 times 18. Well, what we do is we break the 28 into its values. The 2 is a 20 and the 8 is an 8. The 18, we break it into its values. The 1 represents a 10, and the 8 represents an 8. And then what we do is we multiply across. So let's go 10 times 20 is 200. 10 times 8 is 80. 8 times 20 is 2 times 8 is 16 with a 0 on the end. And then 8 times 8 is 64. Now, what do we do with all of these partial products? Well, just like up here, what do we do with partial products? We add them, okay? So what you have to do is go ahead and stack these numbers, and I usually like to stack them from biggest to smallest, and be very careful that when you stack these numbers, you're lining up the places. So the 1's place is lined up, the 10's place is lined up, and the 100's place is lined up. Otherwise, you're going to end up adding incorrectly. So now we add 4 plus 0 plus 0 plus 0 just equals a 4. 6 plus 8 is 14, plus 6 is 20, 20 plus 0 is 20. Put the 2 down, regroup the 2. So now we go 1 plus 2 is 3. 3 plus another 2 is 5. And take a look. We end up with the exact same answer. So both the classic method and the matrix method both work nicely, okay? Now, one thing I do want to point out is if you're going to estimate for the matrix method, it's the exact same estimation, okay? The estimation for the matrix method doesn't change, all right? So you can use the same estimation for both methods, all right? And you are more than welcome to use whichever method you are comfortable with. You don't have to use the classic and you don't have to use the matrix. So now let's take a look at how our actual answer and our estimation compare. Is 600 close enough to 504 that we can say our actual answer is reasonable? Well, yeah. When we're dealing with numbers this big, 504 and 600, if they're less than 100 away from each other, that's still reasonable. So 504 is a reasonable answer. Because it's close to the estimate of 600. Okay, so we can say 504 is a reasonable answer because it's close to the estimate 600. Okay, I hope this helps. Talk to you again soon.